In question number 2, let's see what is given. A fixed pulley is driven by a 100 kg mass falling at a rate of 8.0 meter in 4 seconds. Okay, it lifts a load of 70 kg. Of calculate the power input to the pulley taking the force of gravity on 1 kg or as 10 Newton. So, in question number 2, a fixed pulley is driven by a 100 kg mass falling at a rate of 8.0 meter in 4.0 second. It lifts a load of 75 kg. Of calculate the power input to the pulley taking the force of gravity on 1 kg as 10 Newton. The efficiency of the pulley, and third sub question is the height to which the load is raised in 4.0 second. So first we have to understand why the word driven is used if we are using any pulley. You must have seen that sometime it happens that if we are using a pulley, any body which is fallen down maybe in valley or anywhere, and we want to lift it up, so we use any vehicle or any animal like camel. We tied up this rope there, that animal or any four-wheeler or three-wheeler, whatever is available, that is used here, and that vehicle move forward, that so that this body must lift up. That's why the word driven is used. Now coming to my answer, since fixed pulley is driven by 100 kg mass, that body which driven this rope or stream, weight of that body, it may be an animal or any vehicle, mass of that body is 100 kg. Okay, so that's why it is written in the, since fixed pulley is driven by 100 kg mass, so effort, how much effort this vehicle or this animal is applying, that is mass into acceleration due to gravity, that is m into g, that is the weight. So that's why we have written that effort applied at this point is m into g, that is 100 into 10, that is 1000 Newton. Okay, and we know that formula for power is what? If we are talking about the power at this point, then in place of effort we will write load, and if we are talking about this point where effort is applied, so in place of here we have written effort. So formula is power is equals to effort into displacement upon time. So how much effort applied by that vehicle to pull it up, that is 1000 Newton. 100 kg its own weight into 10, not weight, it is mass, and when we multiply with g, then it became weight. So in place of effort we written 1000, in place of displacement it is given that 8 meter. Okay, and timing was 4 seconds, that's why we multiplied 8 here, in place of displacement 8 meter, and in place of time we have written 4.0 second. So 4 2 and 2 into 1000, that was 2000 watt. It means first answer, the power input to the pulley taking the force of gravity on 1 kg as 10 Newton is equals to power is equal to 2000 watt. Okay, so now next question, to find the efficiency of the pulley. So we know that formula of efficiency is what? That is equals to MA upon VR. So first of all we will calculate the value of MA, that is mechanical advantage, and then velocity ratio, then we will find the ratio of these two data, that is the efficiency of that machine or the pulley. So how we will calculate MA? Mass of load to lift, that is 75 kgf. So weight of the load is what? 75 into 10, that is 750 Newton. Try to understand the body which we need to lift up, weight of that body is not weight, mass of that body is 75 kgf. Okay, and the animal or the vehicle or whoever is applying effort here, mass of that person was 100 kgf. So how much effort this person is applying? 100 into t, that is m into g, mass of this body into g, that is weight. So 1000 Newton force is applied here as effort, and load, so as it is mass of the body which we are going to lift, and we have to multiply that because acceleration due to gravity is also working there. So 75 into 10, it means weight of the body here is 750 and effort is 1000 kg. That's why we have written here that load is 750 Newton and mechanical advantage formula is load upon effort. So right now we have seen that load is 750 and effort is 1000. So 750 upon 1000 is 0.75. Okay, here we are not going to convert it into percentage, it is 0.75 as it is. Now there is single fixed pulley, distance covered by load. Since we know that rule that here is a single pulley, okay, and when we are using single fixed pulley, then if we want to lift it 1 meter, then we need to pull down or pull parallel 1 meter. Equal distance will be covered by load as well as effort. That's why it is written, I have written here that there is single fixed pulley. So rule is that distance covered by load is equal to distance covered by effort, that is D. If we want to lift it 8 meter, so we have to pull 8 meter. Okay, that's why in general I have written only the symbols that D. Therefore velocity ratio is equals to DL upon DE and both distance is D and D. So overall velocity ratio is 1. So finally what is the efficiency? So efficiency formula, the symbol is eta and that is equals to MA upon VR. So 0.75 upon 100. We put the values and that is 75%. This is the efficiency. Last question was, sub question was, the height to which the load is raised is 4.0 second. The height to which the load is raised is 4.0 second. If we are going to pull 8 meter, so naturally this will pull upward 8 meter. Now see, height to which the load is raised is equals to distance covered by the effort, and we know that it is given in our question that effort has covered 8 meter distance, so naturally the load will also lift up 8 meter because there is single pulley.